Hi, welcome to today's lesson on principle of conservation of energy. And in today's lesson, I'll be taking you through this principle, and you have to be attentive as you do so. All right, so we want to look at the principle of conservation of energy. What does it say? Now, that states that energy, as we know it, can neither be created nor destroyed, but can be transformed from one form to another. So what this means is that we cannot actually create or destroy energy, but we can transform them from one form to the other. Remember that the previous video looked at the forms of energy. We looked at kinetic energy, we looked at chemical energy, we looked at heat energy, looked at light energy, and all of this energy. So we can convert one to the other. Example, we can convert electrical energy to mechanical energy. Of course, we see that from the principle of the driving of the blade. So the driving of the blade is mechanical. Electrical energy converting to mechanical, and we can also convert from electrical into light energy. Of course, you remember your bulb, right? Okay, good. All right, so we want to look at we want to focus on mechanical energy for a moment. So mechanical energy. All right, so we want to focus on mechanical energy for a moment. All right, so there are two aspects to mechanical energy. We have one, the kinetic energy. So pardon me, I'll be using abbreviation, kinetic energy. And then we have the other part of mechanical energy, which we call potential energy, PE, kinetic energy and potential energy. Well, I said this in the previous video that kinetic energy has to do with motion. This is due to motion, while potential energy is due to position. That means the position of a thing determines its potential energy. So that means kinetic energy due to motion, then potential energy due to position. So firstly, we're going to be looking at potential energy. All right, potential. I hope I got the spelling right. Potential energy. All right, so let's imagine a ball falling from a height. Let's imagine a ball falling from a height. Let's say it's coming down. Then it has a height from here to here. It has a height h. Then, of course, it's falling under gravity. Acceleration due to gravity acts downward. Okay, good. And remember that this ball or this object has a particular mass, m. So that means there are three factors here: mass, height, and then gravity. Good. And remember that potential energy is a form of energy and it is work done, right? And remember that, let's write it, work done. So potential energy is the same as energy. Energy is the same as work done. So work done is what? Force multiplied by distance. Now in this case, potential energy then now becomes, what's our force here? Force is mass times acceleration. Mass times acceleration, but this time around you're having acceleration due to gravity. So we're going to use A, we're going to use G, acceleration due to gravity. Then multiply by the distance. What's the distance? It's traveling a vertical distance, and that's height, h. And so this is where we get the formula of potential energy equals to mgh. So I want you to put this formula in mind. And sometimes some authors of textbook would actually call this not just potential energy, but they will call it gravitational potential energy. So, but basically, I'll just call that potential energy for simplification sake. So, in the next video, we're going to be looking at examples on how to apply this formula in solving problems as relating to potential energy. So, do not forget to click on the subscribe button as well as the notification button to get notified when I post new videos. Bye.